Welcome to Sairam Triple E YouTube channel. It's a continuation of previous one, Passions Law. In the previous video, we discussed Townsend's streamers and Passions curve also. So that's a continuation. Passions breakdown in a non-uniform field and corona discharge. It is an electric discharge mainly occurring at a non-uniform electric field. Visual and audible discharge, right? Corona. So the corona will occur when the strength of the electric field around the conductor is high enough to form a conductive region but not high enough to cause electrical breakdown or arcing to nearby object. It is often seen that as the bluish other color glow in the air adjacent to the pointed metal conductors carrying high voltage and emits light by the same property as a gas discharge lamp. Potential difference between two electrodes should be greater than threshold voltage 30 kilovolts. So these are the points we should remember. It's a electric discharge mainly occurring in the non-uniform electric field. Visual and audible discharge. It's a corona. It's like a hissing noise, violet glow formation of surrounding the conductor. So result of corona. One is power loss. Everybody knows, right? So it's happening in the conductor. So definitely power loss will be occurring. Hissing noise. I think you might have seen while traveling or while traveling under the high voltage transmission lines. What happens? There is a hissing noise like sound will come, right? So that sound is called as a corona. And ozone formation. So because ionization process will be occurs, because it depends upon the climatic condition, environmental condition. So that's also very important. And the chemical activity. So chemical reaction, it must be happening, right? So while the climatic, I mean like environmental moisture surrounded the transmission lines, what happens? So chemical reactivities must be happening. Factors affecting the corona: air density and humidity are inversely proportional to the corona. Surface conduction is proportional to the corona. Problems associated with the corona: ozone, O3, nitric acid, nitrogen oxide production, electromagnetic interference, audible noise, and insulation losses. So solid dielectrics are commonly used for all kinds of electric circuits and devices. Provide insulating for current carrying conductor. Properties of a good solid dielectric materials are good mechanical strength, free from the gaseous inclusion, free from moisture, and resistance to thermal and chemical deterioration, low dielectric losses, right? So properties of good solid dielectric materials. Types of breakdown in the medium, that is one is intrinsic and ionic breakdown, electronic breakdown, avalanche breakdown, electromechanical breakdown, failure due to tearing and tracking, thermal breakdown, electrochemical breakdown, and a breakdown due to internal discharge, right? So types of breakdown mechanism: intrinsic breakdown, usually small number of conduction electrons of free electrons present in the solid dielectrics. So dielectric material, the following reasons such as a small number of impurities, structural imperfection of dielectric materials are impossible for intrinsic breakdown. The impurity atoms or molecules are both acts as a trap for the conduction electrons up to the certain ranges of electric field and temperature. When these ranges are exceeded, additional electrons in addition to trapped electrons are released, and these electrons participate in the conduction process. The presence of free electrons which are capable of migration through the lattice of the electrics. Process will be repeated until the completion of the electric breakdown solid the electric material. Types of intrinsic breakdown: electronic breakdown, avalanche breakdown. Electronics breakdown due to the presence of large density free electrons in a solid dielectrics. Whenever a high voltage is applied, collision between large free electrons will take place. As a result, electrons gains energy from the electric field and cross the forbidden energy gap from the valence to the conduction band. Eventually, dielectrics breakdown takes place. So avalanche or streamer breakdown. So avalanche streamer theory already we discussed, right? Similar to the breakdown in gases electrics, streamer theory. Avalanche breakdown or streamer breakdowns are in the phenomena that can occurs in both the insulating and semiconducting materials. Both, I mean, like insulating as well as semiconducting materials. It is a form of electric current multiplication that can allow very large current within the materials and causes a dielectric breakdown. First step is the formation of avalanche. Right? Formation of avalanche creates space charge, collection of a charge or a cloud of charge. Space charge leads additional electric field. The electric field enhances the growth of a new avalanche. Ionized region grows quickly expand. When energy gained by the electrons greater than ionization potential, formation of avalanche takes place. Conditions for avalanche breakdown. Breakdown occurs when avalanche exceeds a critical stage. Formation of many avalanche breakdown will be occurred. So like this, it looks right. So see, it's like a neuron network, right? So likewise, it shows. I mean, escaping of electrons or escaping of one to one electrons here. 1, 2, 3, 4, 5, 6, 7 till 17th lines will be there. So how the streaming will be occurring, right? Electromechanical breakdown. Consider the following reasons. Solid electrics are subject to high electric field, electrostatics, compressive force, which can exceed mechanical compressive strength. How do you calculate the maximum value of electric field strength before the breakdown? Consider solid electric material. The thickness of solid electric materials is equal to D naught. Applied voltage is V. Thickness of the applied voltage is equal to D. That means materials is compressed. Thermal breakdown. Mm, so thermal breakdown. Most of the insulating failures in high voltage power apparatus occurs due to thermal breakdown. So if suppose current is flowing through the wire, what happens? I mean conductor. What happens? There is a heavily current is flowing. That time, so the heat will be forming, right? So that thermal heat, I mean temperature increases, widely occurring in the power system components. When the electric field is applied to the dielectric conductor current, however small it may be, flows through the material. So even though dielectric materials conduction will occur, right? If suppose current carries current touches with the material, right? And the current heats up specimen and the temperature rises. The heat generated is transferred to the surroundings medium by conducting through the solid electrics and by radiations from its outer surface. So breakdown due to treeing and tracking. So this type of breakdown occurs when the solid electric material is subject to electric stress for a long time, right? The presence of conducting path inside solid electric materials due to moisture, a mechanism whereby leakage current passes through the conducting path, finally leading to the formation of a spark. Insulation deterioration occurs as a result of this spark. Sparks erodes the surface, generates heat, and the surface becomes dry. The spreading of spark channels said to be tracking in the form of the branches of a tree is called as a tree. As the time passes, breakdown channels spread through the insulation in an irregular tree-like fashion, leading to the formation of a conducting channel. This kinds of channels is called as a treeing. Usually, tracking occurs when even at very low voltage of the order about 100 volts, right? So tracking occurs, I mean, low voltage also, like less voltage also. It's treeing requires high voltage. Treeing requires high voltage, but tracking requires only 100 volts. This is a cumulative process, and insulation failure occurs when a carbonized track bridges the distance between the electrodes, right? So this phenomena happening the layer of bakelite, paper, cable, and similar dielectrics built of laminates. So I told you, right, by the example, So there is a ceramics material, bakelite material, and paper cables. Those are the insulating materials. Okay, electric materials used in the transformer and electrical appliances, electrical components, power system components. That's the thing. Okay, in next class we'll discuss mm, breakdown due to treeing and tucking continuation.